Okay, let's go to the session today. So for today's session, we will deep dive to the first one, RAG and fine-tuning. When should we use RAG? When should we use fine-tuning? The advantage and disadvantage of both solutions. And in the RAG and fine-tuning, I can also explain about multi-prompt. The multi-prompt is the approach that I use in Kenya's GPT. Actually, I also want to explain about React, but sadly I have no time yesterday, so I will skip it to tomorrow. The React is really useful. And then I will talk more about search engine. Like you mentioned, can I talk about more vector? Yeah, somehow, maybe yesterday I also think about this way. So today I will talk deep into word-based and vector-based. Actually, I want to also talk about knowledge graph. It's very helpful in RAG, but maybe it's better to move to tomorrow. And then I will talk about hybrid search and re-ranking, such as how to combine both word-based and vector-based. Instead of using one method, we can combine two. Then we can make a really good engine. And then it's a metadata collection and filtering, the way we enrich our data. Instead of just depend on the entire database, we can generate more tagging, more labeling, like the concept labeling. We can add more label to our data, and it will help a lot in RAG. But I think it is better to explain tomorrow because this concept is quite long. So remind RAG, good at public data set, like the President of the United States or Java, Python, but it's really bad at unpopular language, like if you ask about Troy programming language or ERP solution in Dfocus, they cannot answer because it's very bad. So we have to apply the LM to Dfocus. We use the ability of summarizing the context to do, because why is have that ability? Because ChatGPT learned from internet, and luckily in internet they have a problem called text summarization dataset, and from those dataset ChatGPT will understand how to summarize the dataset. So thanks to that ability, we can apply ChatGPT for our work. So we use user as a question, find related content from our website, and then ask ChatGPT to provide an answer using the context. So here, let's go to the search engine, the thing that we will implement. This is the basic flow for what we do. Given the sentence, dinosaur key holder. First, we have to rewrite the query first. Why we have to rewrite the query? Because when we discuss with the ChatGPT, sometimes we have to discuss in flow. Like we can ask, who is the president of the United States? ChatGPT answer, Donald Trump. Then, was he a businessman? But if you use the sentence, was he a businessman, to the search engine, of course search engine have no idea what is the meaning of he. Then we have to rewrite the query from was he to businessman to was Donald Trump a businessman. Then we're using that sentence for a search engine. There are two basic methods for search engine, the keyword search and vector search. And if we combine this technique, we have the thinking called hybrid search. And from hybrid search, we have a thing called ranking and filtering to filterize all information before display the final search result. So this is the sample output. So remind, two common type of search, keyword-based and vector-based. Keyword-based, we search by keywords, but is sensitive to typos, semantic meaning, and language variation. So in order to overcome this, we have some solution as follows. The first solution, that this is a little bit advanced, that in a database we will generate at much relevant keywords or description as possible, include synonym if exist. For example, this is an example from my ERP Kenya's GPT problem, that I have many categories. From this category, I will apply ChatGPT to make a summarization from that category. And then from this summarization, because sometimes the client also in English, so I will make an abstract in English. And then, but that is not enough, because the keyword base, it strongly depends on the keyword. So I have to keep generating more keywords. And that keyword may come from, first, this is the raw test from our database. And from this raw text, I will make a short summary of the raw text. And then I will extract keywords in this raw text. So the more keyword that I have, the more quality of the keyword base that can come. So that is one solution, adding more keyword. We can add more keyword by applying name entity recognition. That we can use name entity recognition. We have an input. We put to the name entity recognition to find the name of the person, such as Barack Hussein Obama, the location, organization, event that occurred, the date, or other tag. So this tag will help us to enrich our database for keyword base. The second solution that we can apply a vector-based search. Like I mentioned, the vector-based search representing text as a vectors, which can be done by embedded model in embedded model API available in ChatGPT. And because we save all vector in our database, so make sure that the vector can be, the database can be used for vector calculation. So like in here, this is a real example. This is from a data set. We have many keywords. The keyword may be a sentence. It may be a short key. From all of the key, we convert into the vector, and we have the vector form. So while using vector, like I mentioned, the vector will help us to understand the semantics meaning. The texts that have similar semantic meaning, we have to shorten the distance. So now there comes the problem. Here comes the problem. There are many types of embedded vector, and sadly not every embedded vector are equal. Because technically, embedded vector represent the general semantic meaning of a text by vector. Therefore, they have two drawbacks. Number one, if you vectorize a long text, which means that you lost the detail, which means that you can imagine that you have a long text that describes, I'm in Dfocus, I may feel sad for a few days, but Dfocus is a good company, I meet a lot of people, I'm feeling very happy, and blah, 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 which means that the text is very, very long. And somehow you have a short text that about emotional. Of course, the vectorize will not retrieve that long text because the general diagram is not about the emotional. It's just about the working area. But what happens if you vectorize a short text? Because the short text, technically that is short, so it will lack of context and limited expressiveness. If imagine you have a really long paragraph and you crop the paragraph into short sentence, then if you vectorize those short sentences, you will lose the entire semantic meaning. Like I mentioned, I say, maybe the short sentence may be, sometimes I feel sad and tired. But if you vectorize that text, it just becomes your emotional, negative emotional. So that is the drawback. And the second drawback is that not every embedded models are equal. Some models work really well on the long text, such as BERT or ChatGPT or GBT, because GBT, like you say, like you can see, most of the time they work with really long paragraph and to generate the output, long output. So if you use a GBT model for embedded vector for a long paragraph, then it can understand the semantic meaning. But if you want to use embedded vector, embedded model to a short word, then you have to use word2vec and Clove. Because word2vec, technically, they understand how to embed it in word level, not a sentence level. The basic foundation of word2vec is try to predict a one single word in the blank, fill in the blank, like Dehan Salam, Dehan and the blank. Then they learn how to implement the next word. So that's why word2vec is very useful for short text. But if we apply word2vec to a long text, it's fail. Then another drawback of this approach is that what happens if we store too many vectors in our database? The database comes in very huge amount. And given the entire database, given the entire conversation we will not encode the entire of conversation into one vector. We don't do that. We have to chunk and split the paragraph, depend on the topic. So the more you chunk, the more vector that you have, and the more memories that you will need to store in our database. And that will make our thing into trouble. So what is the trouble? Because when we do the cosine similarity search, technically we are applying a brute force for vector calculation. So you can imagine you have 1,000 and millions of vectors. The brute force approach will spend lots of time. It has high computational cost and time consuming. So how can we solve this problem? So in practice, we don't find the exact matching, the exact information. We will try to approximate the information. So how can we do the approximate information? Let's say that the blue dot, that is our vector in our vector database, is semantic. So instead of applying cosine similarity search or vector calculation on each and every blue dot, don't do that. Before that, let's do some text processing. Vector processing. I don't know if you have familiar with the word k-mean or something, clustering in machine learning. So the first one, we will apply a technical clustering in machine learning that will try to cluster your entire vector in database into some group, and you represent each group by a red dot. Red dot, that technically that is another vector, the centroid of that group. So given a vector, first number one, you will find a centroid, corresponding centroid. So you can see that in blue dot, maybe you have hundreds of dots, but if you come to centroid, you just have 7. So you can apply the full brute force on each centroid. So after you apply a centroid, maybe you find, maybe centroid number 1 is the closest match. Then from the centroid number 1, you will take all of the blue dot in the number 1 and match with our user query and return the values. Of course, this is just a way to approximate. We cannot find exact matching, but in practice, because our products should be in real time and low latency, so that is the way we should do. Of course, there are many ways to do the approximation, such as you can search on the internet about the method called HNSW or approach neural network or ANOI. That is also the way to do the vector approximate. Okay, so let's make a comparison between word-based and vector-based. So should we use the vector-based all the time? The answer is no. Sometimes word-based is useful. So before we say which one is useful, let's make a comparison between word-based and vector-based. The word-based, they use the exact word or phrase to match the query. But vector-based, they use mathematical vectors to represent the text. So in the search mechanism, the word-based, they use keyword matching, and vector-based, they use semantic understanding. So now here's come to advantage and disadvantage of both. The advantage of a word-based is that first, it's very simple and very fast. You can apply directly on SQL or anywhere. It's very simple. And because we just, instead of applying on the paragraph, maybe we just represent the paragraph by a few keywords. So it saves us a lot of time. It's easy to implement and it's transparent and has a predictable result. And the advantage of vector-based is that it can handle synonyms. It also can handle typos. It can understand the context and semantic meaning, and more flexible with language. Although your database is in Korean, but if you use English, then no problem for a retrieval. And the disadvantage of keyword-based is that they require to exact matching of the keywords. And it fails with synonym and paraphrasing, and it can miss relevant result if the exact keyword aren't used. But the disadvantage of vector-based is computational expensive, require more complex setup, and results can sometimes be less interpretable. It depends on how you set up the threshold calculation. So when should we use both a keyword and vector? You use the keyword if you need exact matching of the data. For example, when I developed the Canvas SQL, because I should work with SQL, so which means I should work with table name, column name, and the table name and column name must be exact. It cannot be approximate. If I approximate, I will misunderstanding to another table, to another the column, which is not good. So if you use the simple lookup task, you use the keyword base, it saves your time. Or if the exact keyword matching is crucial, then you have to follow the keyword base, not the vector base. And in case of you have to work with complex query or you need to require understanding of context, then let's go to the vector base. Or if you're dealing with ambiguous or nuanced text, let's use the vector base. Or if you have large data set and diverse vocabulary, vector base is very useful. So this is the short summarization when to use most cases, when to use word-based and when to use vector-based. So summarize, word-based, when the precision is the key, you need the exact matching, then let's follow the word-based. Or if you have some simple application or your resource is or your system resources are limited, such as you have to have the simple PC like me, then you have no choice but follow the word-based. Because we don't have a strong PC. And you follow the vector base if you have the rich language task or handling large and diverse data set or improving user experience. Then let's use the vector base. Which method will you choose? Word based or vector based? With me, let's using both. Why you have to select when you can use both? So because when you use both, which means that we have a search called hybrid search. The hybrid search is that we will apply both word-based and vector-based for searching. Let's take example. In the Canvas GPT, a user sent this question to me. Then I will apply both approach. In the vector-based, I will first make a kind of a name entity recognition that find the entity like collector, Tuka, find the entity, and then follow the vector base to find the top matching score. And then simultaneously, I also, this one is a word base. And simultaneously, I will apply the vector base to find the top matching score. I use the word base to search a list of keywords to find collector and collector Tuka. Because like I said before, I already have the database of keywords. Then I can say, okay, let's select the information that appear in post search. And that is my final answer. Thus that it will increase the quality of the search engine. So do both methods are equal? Like if the thing appear in the vector base and the thing also appear in word base, that both are equal? The answer is no. Because in practice, some methods are better than others. So instead of judging everything equally, let's adjust some priority. And this adjusting of priority leading to a technique called re-ranking, re-rank our search value. So this is the entire process of hybrid search and re-ranking. So let me show you the this general diagram. So you have a search query. You apply the vector search and keyword search in your database. In your vector search, you will have your relevant chunk. In your keyword search on the database, you also have another relevant chunk. Then you start merging those chunks and apply some re-ranking to scoring the score of each chunk. And you make a short, and you have your final result. So technically, how can it work in practice? So let's look at this diagram. Let's say a query, someone search for a word screwdrivers. Then you will add a word-based. The BM25 is a word-based approach. And you can add to a vector-based. Clip search and expert, that is a vector-based. So you will have three search engine. So with BM25, this is the list that you have. Let me zoom in. This is the list that you have. And for the clip search, you will have your corresponding result. For expert, you also have your corresponding rank, corresponding result. So you can see in here that there are, let me erase that, okay. You can see that there are some results that appear in both three cases, such as you can look at B0008RCN, that they appear in both such, but some such that appear in one type of such or two type of such. Not everything appear in the same amount. And also you can see that the scoring also different. The BM25 score is 3, 10, 15, but the scoring of Clip and S-BERT is just 0.71 or 0.82 something. So before doing any re-ranking, you have to normalize everything belong to 0 and 1. So in this step, you can see that from the 15, 10, and 3, I will normalize the score to the score belong to 0 and 1. So you can see that in normalization, the score will be 0.61, 0.5, and 0.28. Now it's time for re-ranking. Like I said, there are some results that appear in one search but not appear in the others. So how can we re-rank this case? So one solution we will do, that is the interpolation. Let's say, for example, the 1, 2, 3 in the normalization, that is the result from BM25. But you can see that in the interpolation, A003 is not appear in BM25. C00 is also not appear in BM25. So how can we adjust the score? One way to adjust the score is that we adjust the minimum score. So you can see that the minimum score in normalization is 0.28. So all of the keyword that not appear in BM25, we also assign 0.28. And we follow the same approach for clip search and S-BERT search.
So I have a question.
Yes, sir.
As I know, BM25 is a kind of keyword
Yes.
dictionary. But it's sentence embedding, as I know. What is a clip search?
Clip search, as I search on the internet, it's also another type of vector matching. Yeah. Then we start applying the weighting function because, like I said, not every search are equal. Some search are better than others. So in this case, BM25, because that is the keyword base, so sometimes they can forget the meaning, forget the semantical meaning. So I will assign it with the lowest lowest weighting function, which is 0.1. Clip search and S-BERT, that is the vector. The vector quality usually perform better than the word case. So I can assign a different weight, such as 0.4 and 0.5. I can say that S-BERT is slightly better than Clip. So I can say Clip's weight is 0.4 and S-BERT is 0.5. Then finally, I will start applying re-ranking. I'm making a score. 0.61 multiplied by 0.1. You can see that the score 0.61 come from the BM25, 0.82 come from Clip, 0.71 come from S-BERT. Then I multiply it with the weight and has the final score of B008 is 0.74. Then finally, I just simply shorten the result and select the top. So that is the way we applied hybrid search in practice. Then after selection, we just simply feed it to the prompt easily. So this is the process with our RAG and with RAG. With the RAG, we have the user. This is the input. You can see that in practice, the input is very long. So from the input, we have to manage the query. We have maybe sometimes we have to do analyze, deep analyze on the input, then feed to the vector and do some embedding and do some relevant document retrieval. And we have 3 chunks. And we feed to the chunk into the ChatGPT. So you can see that this is the input of ChatGPT. The input containing the question and the relevant information, which is the chunk. So usually in Dfocus, the GPT, the chunk number 1 is the thing that have the highest score in retrieval. Chunk number 2 is the second highest. Chunk number 3 is the third highest. But obviously in practice, we're never sure that the highest will be the most relevant. We're not sure.
So from that, can
Yeah.
I have a short explain of that hybrid search
Okay.
before that
Okay.
hybrid search?
Please.
일단은 요거를 이해하기 전에 하이브리드 서치를 조금만 더 생각을 하고 가면은 항상 그랬듯이 솔루션 A랑 B가 있으면 A랑 B는 항상 장단점이 있거든요. 각자가 서로가 이제 못하는 걸 얘가 하고 얘가 잘하는 걸 얘가 하고 그래서 각자 도메인에 어울리는 솔루션들을 사용을 하는데
서치 엔진
네, 특히 뭐 어휘 기반이라고 하면은 보통 저희 검색 엔진에서는 역색인이라고 저희가 챗봇이라고 쳤을 때 챗봇이 들어간 문서를 지금 다 찾아오는 게 아니라 챗봇이 들어간 문서들을 기존에 문서 번호들을 정리해 놓고 그 해당 문서 번호를 갖고 오거든요. 그래서 그게 워드 베이스 서치인데 이제 이걸로 뭔가 실제 LLM과 소통을 하고 LLM이 저희의 의도를 파악하기에는 이건 어디까지 정말 어휘 베이스예요. 그래서 워드 베이스 서치가 기존에 검색 엔진이랑 쇼핑몰 같은 곳에 있었고 근데 이제 벡터 서치가 나오면서 어휘가 하나도 뭔가 일치하지 않아도 인위적으로 일치하면 갖고 올 수 있다. 근데 이 과정에서도 고객이 질문이 짧거나 했을 때 정말 어휘 하나인데 그 어휘 하나로 의도를 파악할 수가 없는 경우가 있잖아요. 그럴 때는 BM25라고 그 하는 워드베이스가 정확하고 그래서 각자의 장단점이 있다 보니까 이 둘을 조합을 해서 원래 10개의 매터리얼을 갖고 오는데 5개씩 갖고 와서 보여주면은 챗봇이 조금 더 LLM이 이해를 하는데 정확하지 않을까. 그래서 릴리번트 도큐먼트를 가져오는 과정에서 이제 저희 하이브리드 서치가 필요한데 저 과정에서 원래는 벡터 서치만 사용할 수 있고 워드 베이스 서치만 사용할 수 있는데 그거를 같이 혼용을 해서 갖고 오면은 저 릴리번트 도큐먼트를 갖고 오는 과정에서 정확한 문서를 갖고 올 것이다. 저거를 좋은 유용한 문서를 갖고 오지 못하면 결국엔 LLM을 답을 못하기 때문에 짧고 길고 의미가 있고 없고를 파악을 하는 데 있어서 두 가지 서치를 결합을 하는 게 하이브리드 서치입니다. 장단점이 각자 있기 때문에 혼합을 해서 사용하고 있다고 보시면 됩니다.
그걸 우리가 이렇게 그 RNG를 구축할 때 우리가 뭐 엔진을 선정을 하거나 이렇게 적용을 하고 뭐 그럴 수 있는 거죠?
그럴 수 있습니다. 충분히. 제일 많이 사용하는 게 이제 워드 베이스 서치에서는 그냥 엘라스틱 서치라는 솔루션을 제일 많이 사용합니다. 그 안에 데이터를 다 색인해서 넣어놓고 진짜 사용법도 어렵진 않은데
RAG하고 서치 엔진 사이의 관계는 서치 엔진은 RAG를 하는 툴
네, 이제 릴리번트한 관계 있는 문서를 가져다 주기 위해서
툴이다.
네, 서치 엔진은 그렇게.
Okay, so shall we keep going?
Yes,
Okay.
please.
So now it's come to the drawback of RAG. The first drawback is that not all positions are equal. What does that mean? Like I say, when I place on here, the chunk 1 usually is the top, the highest matching. The chunk 2 is the second highest matching. The chunk 3 is the third highest matching. But what happens if the correct answer is chunk 3 or chunk 4 or chunk 5? We will not guarantee the chunk 1 will always be the highest matching. We cannot guarantee that. So that is one RAG drawback, that not all positions are equal. That there are some research on scientific about generative AI and large language model, and they found out that large language model is biased toward to a certain position. For example, there are two prompts. One prompt say both prompt says that which response is better. The first one place response number 1, then response number 2. The second place response number 2, then response number 1. And they found out that although the same question, but that if they put to GPT-4, if this case the response number 1 come before response number 2, the answer is response number 1. But if response number 2 come before response number 1, the answer is response number 2, which means that it's uncertainty. Same question, same reference, but just the way we arrange the position of the reference, the answer is different. So that is one drawback of RAG. Not all positions are equal.
Position exactly means here?
Yeah, the position is that the place you put your relevant data after re-ranking to here.
Re-ranking position.
Yeah, re-ranking position. Okay. So usually the ranking position, I place the number 1 is the highest score, the highest match. The second is the second highest match. The third is the third highest match. But in practice, sometimes The fourth highest match is the correct answer. We can tell. Maybe the fifth, maybe the one. So at first I expect ChatGPT can select a good answer for me, but turns out it's not. The LLM, some scientists found out that LLM is biased toward a certain position. So you have same question, but you just place your chunking, place your relevant information in different position. Your answer will also be different. If you place response number 1 first and response number 2 second, then it will likely ChatGPT will answer response number 1 first. Maybe all or response number 1. But if you say response number 2 first, response number 1 second, ChatGPT will take response number 2 to answer. So that's one drawback. In this search, they also make another experiment is that same prompt, they say scoring each response in the scale on the scale of 1 to 10. And they place response number 1 before response number 2, then response number 2 before response number 1. And they found out that which response come first usually receive the higher score than others. In this one, response number 1 come first, response number 2 come second, so response number 1 received the 0.9, number 2 received the 0.7. In this one, because response number 2 come first, response number 1 come later, so response number 2 right now received the score is 9, and response number 1 received the score is 7. So same question, same relevant answer, just rearrange, just shortening the position, softening the position, the answer will totally be different. And they also make the entire experiment on a specific problem, such as multi-document Q&A. You give the question, you give the document, and provide the answer. Another is a code completion. You give in the code and complete the code. The third is the summarization. You give in the paragraph and you try to summarize the paragraph. And in their task is that they will try feeding the relevant document in the prompt. And they found out that the more document they feed into the prompt, the quality is totally different. Such as, for example, for the Q&A, the more document that they add, the performance is reducing by the day. That's one problem. The summarization, it turns out is so the different meaning. If you work with summarization and you add maybe around 10 relevant document, you achieve the highest accuracy, like 100%. But if you add like 15, the accuracy will suddenly drop and drop and drop. And it's similar happen in code completion. So that is one drawback of RAG, the position matter. Yeah, so the next session will be fine-tuning, but I think that before fine-tuning, maybe we have maybe 10 minutes break. Okay, welcome to the afternoon session. Hope you have a good lunch and good rest in this lunchtime. So in this morning, we are talking about the RAG drawback. That one of the drawback of RAG is that the position bias. Some position that RAG looks like have given a priority other than position. Then it may lead to RAG produce incorrect answer, although we already retrieve necessary content. So one way to overcome this problem and whether we should fine-tune the LLM or not. So let's study what is the meaning of fine-tune and the advantage and disadvantage of fine-tuning. So let's go back to the original question. The LLM, usually they are training on public dataset. They know about public knowledge, about Python, about C++. But in Dfocus, we are using Troya programming language. We have our specific ERP solution, which is obviously ChatGPT doesn't know about that. So how to apply LLM to Dfocus? Another solution is that let's fine-tune the LLM with our Dfocus dataset. Before that, let's understand what is the meaning of fine-tuning. The fine-tuning meaning is that you are applying a pre-trained model to a specific domain. You can imagine that you have the knowledge of mathematics and your daughter is the first time studying mathematics. because you already know mathematics. You teach your daughter knowledge about mathematics. So the way of teaching, that is kind of calling fine tuning. Or specifically in AI, that ChatGPT, this is a retrained model. They already have a knowledge on the internet. They know how to summarize the document. They know how to classify a document, but that is a public document. Then we can apply that ability to teach the model with the, for example, ERP solution of Dfocus company. Or so by applying the ChatGPT to train the ERP solution of Dfocus company, the user right now can use ChatGPT to ask some problem related to ERP, and ChatGPT can generate a response that related to ERP. Instead of calling to Dfocus, now they can use the ChatGPT. So now we will teach ChatGPT by using the information from our company. So let's see how we can teach the ChatGPT. So the target of fine-tuning the LLM is that we will let ChatGPT learn from our work, from our own dataset. So there are 3 steps in the fine-tuning. The first step is that we will prepare and upload our own training data. The second step is that we will start training a new fine-tuned model. And the third, we will deploy the fine-tuned model to the public. So how can we train the data? This step we are calling the labeling. Is that maybe you remember this image, right? This image is the supervised fine-tuning from LLM, from ChatGPT. So when we fine-tune the data, we will format our dataset following this fine-tuning, following this format. The prompt right here will be the input to the model, and the response right here will be the output of the model. We should label our data like that. First, we will prepare the prompt, the question, the issues, anything that the user can ask, and the response will be the things that we usually answer to the customer. So we'll be prepared in this format, prompt and response. So one example, the format may be in JSON. The format will be JSON like this, like prompt will be what is Dfocus ERP solution, and the response will be some blah blah blah. Dfocus ERP is something something something, and we provide at least a few hundreds high quality example. This is at least, because in practice, the more data you have, the better the model will learn, but at least a few hundred and high quality example. So in detail, is that first we will set up the data in the structure of prompt and response format. This step we will call labeling. The prompt will be the input to the model, and the response will be the output of the model. And then we will set up a training set to train the model and testing set to evaluate the model. If you are familiar with AI or machine learning, maybe you already know this hyperparameter. This is the number of epochs, the number of learning rate, and the number of batch size. The number of epochs, you can say that is kind of the number of loop, the number of time you're looping throughout the training data set and you learn. The learning rate, you can imagine that is the value to update the rate to update the entire parameters in the deep learning model. And the batch size is, you can imagine that is the number of data that can learn at the same time, because we are using GPU, so AI model can learn multiple data at one time thanks to the GPU. So that is a batch size we are using. This is a recommendation from OpenAI. If we fine-tuning in OpenAI, you can follow this recommendation. I don't know how, but maybe you can follow this step. That the saying that maybe if the model fine-tuning, when doing with fine-tuning, we see that looks like the quality is not good, maybe we need to increase the number of epochs, the number of loops, just increase so that the model can learn more. Or if the model start become less diverse, less generalized, then we should decrease the epochs. And if the model is not appear to be converging, like they cannot learn anything at all, we can increase the learning rate so that the the rate of updating parameters will be increased. So this is the example graph during we during we fine-tuning a LLM model. That we have the validation loss, training loss, validation mean accuracy, and training mean accuracy. In the validation loss and training loss, we're expecting that the loss will be as small as possible. The smaller of the training loss and the smaller of validation loss, the better of the model, which means that the output, prediction output, and our correct output in labeling is matched together, start matching together. That's why the loss, the difference between the prediction and the correct label is start getting closer and closer. So the lower the loss, the better of the model. And also we can check the accuracy of the model, that to check whether if the token prediction is correct or not, whether the model will stop or not. So this is kind of 4 parameters we will check during fine-tuning. So this is the general process of fine-tuning. We set up the data set. We format the data set. That is called labeling. Then we set up training set. We set up testing set. We set up model hyperparameters such as number of epochs, which is number of loops, the learning rate, the SOCTO for updating the parameters, and the batch size, the number of data can be learned at the same time. And we should check the process of training data. This is just an example because in practice will be more complicated than this. So what is the problem of fine-tuning? We already discussed the negative, the disadvantage of RAG. Fine-tuning also, they also have their disadvantage. One of the disadvantage of fine-tuning is that catastrophic forgetting. So I can explain simple like that. When you study in high school, you study mathematics, you study physics, you study maybe Google, which you study English. Then when you go to university, maybe more time you start learning about mathematics, advanced computer science, but looks like you never use chemistry, you never use literature. And after more and more years, you're really good at mathematics, you're really good at computer science, but you can unable to do any chemistry problem. So that is also one problem that happens when you're fine-tuning the model. That is catastrophic forgetting. Specifically that a Gen AI model, originally they can learn how to summarize the data. They can learn how to classify the data. The task will be summarize the document. The task will be generating suggesting a solution, which means that the classification is no longer used. The maybe code checking is no longer used, and other function of ChatGPT is no longer used. So if for some reason we want to use the function, the fine-tuning model is not available anymore because that is a problem of fine-tuning, catastrophic forgetting. In a mathematical way or in technical information, it caused by data distribution shift because our data set mostly focus on summarization and suggestion. So other distribution such as classification is no longer used. Then the parameters in ChatGPT start shifting toward how to summarize good, how to suggesting good, and they start forgetting other abilities. So this problem is we'll lose some ability of the original LLM since the model is now learning toward a new task. So you can look at this meme. This is one way to illustrate the problem of fine-tuning. Actually, there are many methods trying to overcome this catastrophic forgetting, but it's kind of still difficult and challenging, and many researchers trying to solve this problem. One way to solve is that you can imagine if you go to university, you study mathematics, and you're afraid of forgetting chemistry. One solution is just study chemistry, then you will not forget it. So we can apply that situation to fine-tuning. When we labeling the data, let's make the data as diverse and variety as possible, such that we ask ChatGPT to learn in multitask, such as ChatGPT can learn how to summarize data, learn how to do Q&A, learn how to extract keyword, learn how to make sentimental analysis. All of this step is called labeling. We also have to label how to do that also. Then another problem
can I understand this way?
Yeah.
before fine tuning this LLM, he has 10 areas of intelligence
Yeah,
from English to
many, yeah,
but for specific purposes we trained mathematically mathematical area
yeah,
focused, and he after the fine tuning he forgot about the other area.
yeah. So in order to fine tuning successfully, at first you have to determine which function that ChatGPT should work. So like listing,
It's
summarize,
sort of a
Q&A, yeah.
capacity problem. Seems to me he has a limited capacity,
Yep,
so he has 10 things in a box, but one if one grows, others are
disappear,
getting
yeah,
out, right?
kind of. So that is one problem of fine tuning. So before fine tuning, we should determine the task carefully. And another problem of fine tuning is the risk of overfitting. I will explain like this, like it's kind of like you learn something on the school, but instead of understand the problem, you just learn by heart. You just try to memorize it. And when you go to Sunung, you go to the test, you lose the ability of generalization and you fail. So that is a kind of explain of overfitting in LLM. It happens if our data set is too small. It starts to memorize. So you lose the ability of generalization. For example, one client asked, my phone is broken, how to solve this problem? And the dataset is saying, please call to Lee Chung Ho Samuni. And when you deploy in the practice, one guy said, my PC is broken. Then the LM will say, oh, let's contact to Lee Chung Ho Samuni. Actually, that is a false information. So that is a problem of overfitting. It's losing the way of generalization. And because they lose the ability of generalization, it increases the risk of hallucination. It generates a fake answer, incorrect answer. Another problem that can come in fine tuning is that garbage in, garbage out. This problem mostly comes from our data set, which means when we do the labeling, we do incorrectly. We pre-process the text incorrectly. And we like anything on the data set is incorrectly. It makes our data set quality is very bad, and it leads to bad quality outcome. You can imagine that when the customer call, we have the API, the speech to text API, to generate the text. But the text sometimes is incorrect. Sometimes they forget the comma. Sometimes they forget the period. Sometimes they forget to capital the word. But you don't solve that problem. You just put everything to the LLM. Then LLM will also generate a bad quality outcome. The output, no comma, no period, no capitals, because technically generative AI learn from the data. Or
That's a golden rule for every single course
yeah,
data science.
so that's why I always repeat many times, Gen AI learn from the data. So you have to be careful of the data. Another problem is that biased data set. This is the thing that causes everyone crazy. In your data set, maybe some data set is about summarization. Some data sets is about instruction. Some data sets is about maybe keyword extraction. But obviously, the distribution of them are not equal. Maybe summarization, the number of amount of data in summarization is really huge, but the number of amount of data in instruction is really small. So it leads the fine-tuning model become biased. If you ask the LLM after fine-tuning, if you ask the LLM for summarize, it's performed very good. But if you ask LLM for instructing customer, certainly you see many hallucination effect. It's come from the biased data set. One way to explain is that such that the public ChatGPT right now, 60% of them training in English. So if you ask something in English, ChatGPT can answer very good. But if you ask something in Korean, sometimes the quality is not as good as English. So that is a problem of preparing the dataset, the bias problem. And another problem of fine-tuning is that the maintenance complexity. We see in this one, we spend lots of time for fine-tuning. We have to check the laws, we have to check the train. Sometimes we cannot guarantee to correct at the first place. Sometimes you have to revise your data again, and you back up your data, you retrain the model, it spends lots of time. So it leads to one thing, it's called maintenance complexity, that when you're fine-tuning the model, you spend a lot of time. The customer call every day, every week, every minute, every hour. So the new data come frequently. So what happens if the new data comes frequently? We have to fine-tune the model frequently. That is a must. So when I say fine-tune the model frequently, it means that we have to re-labeling the data frequently. We have to pre-processing the data frequently and repair the data, anything frequently. That is the thing we have to repair. So the question is right now, when should we use fine-tuning? There are suggestions on the internet that if an LLM never learned anything before, such as Troya programming language, LLM never learned, then that is a good time to apply fine-tuning, because technically LLM never learned. So one way to solve that is just fine-tuning. So one reason to use fine-tuning is a rare specific domain that LLM never learned. If LLM did learn, then maybe we should not use fine-tuning. Or we have a unique writing style. Right now we are using summarization or suggestion. But for some reason you want the summarization or suggestion should follow models of speaking style. Of course, ChatGPT did not learn to do that. So at that time you have a unique writing style, then that is a good time to apply fine-tuning. And the third reason to use fine-tuning is that the data set is guaranteed to be well established and stable for a long period of time, such as the Hunpap, the Constitution of Korean, is stable and guaranteed to not change for a long of time. Or our Dfocus company rule is stable for a long period of time. So at that time, we don't need to spend more time to frequently update and update. So that time we can use fine tuning.
We can use fine tuning.
We can you able to use. So in the case of data is well established and stable for a long time, then we can use fine tuning. So now let's make a comparison. Yeah.
Does that means sort of unstable data
Yeah.
is not
It's not recommended.
for fine tuning?
Yeah. If the data is frequently updated, it's not recommended. So yeah, stock price or dollar rate exchange, no one can fine tune that because it's just update all the time. So let's compare between RAG and fine tuning so that we have the general image. Let's go with RAG first. The advantage of RAG is that because the RAG is based on a searching engine, so it can helpful on up-to-date information. You have the new information, you just put to the database and you run for a search engine, take that database and input to an LLM, then LLM generate the output. So one big advantage of RAG is that they can help to up-to-date information. And the second approach, the second advantage of RAG is that it's flexibility. They can answer a wide range of query without needing extensive retraining because we're just using RAG, we don't need to retrain. And technically, GenAI has many ability to do summarization, keyword extraction, many ability. So it's very flexibility to apply RAG. And the third approach is the scalability, that RAG can handle a large and diverse knowledge base. Your knowledge base, your data set your database has information for summarization, information about reporting, information about maybe sentimental. You have different variety of diverse knowledge base, but thanks to the search engine, you can load it and just rewriting the prompt, adjusting the prompt, then the ChatGPT can generate a suitable output. But like I say, RT also has the disadvantage. One disadvantage that is that the complexity of the search engine. When I introduced about the vector, sometimes you have to store the vector on your database. And if your vector is too much, then the search engine will spend more time for finding relevant data. The second disadvantage is the latency, because we are searching and our data set is huge, so sometimes we have to break into sub-step. finding the big group, from big group finding the small group, and sometimes we have to combine this information to another information and apply the hybrid search and adjusting and selecting information. It can lead to the latency, 1 or 2 second delay. And the third disadvantage is strongly depend on the retrieval quality. Although I introduced about word-based retrieval, vector-based retrieval, hybrid search, but if we manage the search engine incorrectly, we can retrieve incorrect information. That thing happened right now in the Microsoft Copilot. Microsoft Copilot, they introduced a LLM model. I forgot the name of the LLM model. But when I ask one question, how much time from here until May 23rd? So instead of calculation, the Microsoft just say, in May 23rd, we have a lot of event, which means that the retrieval is incorrect. I ask about how much time. They just say, this day have some event. So the retrieval has some problem. It leads to ChatGPT also produce incorrect answer. So now let's go to the fine tuning. Advanced fine tuning also have their advantage and disadvantage. One advantage of fine tuning is that we can optimize LLM for our specific task. We suggest for Troyer programming language, we can teach LLM for teaching Troyer programming language, analyze Troyer programming code, language code. Another advantage of fine tuning is the consistency, because right now we don't need to retrieval anymore. We already trained the model. We don't need to retrieval, which means that maybe we don't need the search engine anymore. ChatGPT can generate the answer immediately because it already fine-tuned. And because we are no longer use the search engine, it can reduce the latency, just like you are using ChatGPT right now, one input, one output immediately. But now it's come to disadvantage of the fine-tuning. Number one is the resource, because LLM it has billions and trillions of parameters, so it requires significant computational resources and time for training. So we have to spend time for fine-tuning the model, for preparing the data set. So that is one disadvantage. And the second disadvantage is the overfitting risk. If our data is too small, it can lead to overfitting and it can lead to more hallucination. And the third disadvantage is the static knowledge, because you already fine-tuned the information. So if for some reason you ask for a new information, of course ChatGPT cannot generate a new information. So everything will be fixed. So that's why I say if you want to fine-tune, you have to select which data that's stable for a long time.
Sorry.
Yep.
So disadvantage is a static knowledge.
Yeah, so that is an advantage that they can apply for a task specific in LLM.
You said stable data is recommended.
Yep.
For fine tuning.
Exactly.
I feel a bit of a confusing in between stable data and static knowledge.
Okay. It means that you have this. I mean that before I mentioned about stable data. In this, I mentioned about you just fine tuning without worry about stable or unstable. You have any data, you just put to the fine tuning.
The result of fine tuning can cause static knowledge.
Yes. So if you have new information, you have to fine tune the data, fine tune the model again. Yeah.
Can you just compare, like this way, the advantage of RAG and advantage of fine tuning?
Now we can go to the next slide. I can discuss about that.
Okay.
On the next slide. Okay, so when should we use RAG and when should we use fine tuning? It's recommended to use RAG when the dynamic knowledge is crucial. The data often update frequently.
So unstable data,
Yep. So
dynamic data is recommended for RAG rather than
fine tuning.
Fine tuning.
Just using RAG. Or the broad, or if another approach is when you need to handle queries from a wide range of topics without specializing any single one. This one is meaning that the LLM has many capability, so it can have a wide range of domain. And if you have no specific reason, no specific kind of technical, then you can apply RAG. The third is the resource constraint. Like if we don't have the machine, of course, Dfocus have no machine, so let's use RAG. And the scalability is that if the update external knowledge base appear frequently and large, so we can use the fine-tuning RAG. So when should we use fine-tuning? We use fine-tuning when we need something specialization, especially LLM never exist. There's some ability that LLM never see before. The second reason is that we can use consistent and low latency response. Is that for some reason you see that you need a real-time reply and our search engine is too slow to perform RAG, then maybe you can consider about fine-tuning. I just say the word consider. I don't say we should. Yeah. And the third reason to use fine-tuning, if your knowledge is static and unchanged for a long time, then you can use fine-tuning. And the fourth reason to use fine-tuning is that we have controlled environment. You can afford computational resource, and you know how much time for training. You have a process to pre-process the data, to labeling the data, which means that everything is in the pipeline. Then just apply the fine-tuning because you know the process. So what should we do? Should we do RAG or should we do fine-tuning? It's similar to search engine. Like I say, should we do word-based search or vector-based search? And I say the answer is let's combine both. So this one is similar. Should we use RAG or fine-tuning? Let's combine both. Why we have to select when we can do both? Okay, one way to utilize both tabs is that we can apply fine-tuning and RAG at the same time. We can combine both RAG and fine-tuning. It can be potential. For example, it say that you select some stable data, you determine domain specific, and you start training the model on that problem. And then for some reason, if the new data set comes and the new domain comes, then you will start applying the RAG on your on your fine-tuning model. So we can apply both. We don't need to select one or two. So what is the advantage of that? First, because you are applying RAG, so you also maintain the up-to-date information. You don't miss because you have RAG. And because you fine-tune the model on your specific domain, so LLM right now, they have the specialized knowledge, information. Then LLM may be guaranteed to follow that specific style of response. Another advantage is that they can improve generalization. So when we combine fine-tuning and we combine retrieval, we can generalize better across diverse query. And the fourth advantage is their scalability and flexibility, that we can handle a wide range of queries by follow the retrieval mechanism and make it suitable for application requiring both breadth and depth of the knowledge. Yeah, so in practice, we can apply both. We don't need to select one or two.
Can I
Yep.
try to check my understanding?
Okay, so.
I love quadrant approach.
Yeah. Okay, shall we come back and keep going?
Yes.
Okay, let's start. I don't know if it's good news or bad news. We have 10 more slides left.
Very good.
Okay, so let's remind about RAG and fine-tuning. We have different strategy of AI and fine-tuning. We discuss about advantage and disadvantage of RAG and fine-tuning. And I also write some recommendation when should we use RAG, when we use fine-tuning. And we can apply the hybrid approach that we can combine both RAG and fine-tuning. It will leverage both advantage of RAG and fine tuning. So let's jump for more detail about when to use fine tuning. So luckily, I'm really glad that OpenAI platform they provide a lot of materials and tutorials for us. So if you have time, you can visit the OpenAI platform website. Then they have a lot of knowledge for you to study about LLM. So OpenAI, when they released the ChatGPT 3.5, a lot of people ask about fine-tuning the model, but they face a lot of challenge. If we fine-tune a ChatGPT model, you have to pay more on your fine-tune device, including the input tokens, output token, the money will increase. Also, you spend many times for learning, for preparing your data set, normalizing your data set. So then ChatGPT, the OpenAI, they have some suggestion whether we should fine-tune or not. In their recommendation, as I highlight above, they recommend that first, let's try with prompt engineering first, prompt chaining first, RAG first, before jumping to fine-tuning. If prompt engineering is good, prompt chaining also good, and RAG is also good, then obviously no reason we have to fine-tune. So that is the first step. Let's try with RAG first because it's easy to do. The reason is that although there are many tasks that ChatGPT at first not work well, but if we adjust the input, then the outcome will also be good. Such as I already present the prompt on previous slides. We just adjusting the prompt, then the output will be good. At that time, the fine-tune may not be necessary anymore. And then because fine-tuning usually we have to creating a data set, we have to running training jobs, so it will take many time. So if we test with the prompt engineering, then we iterating over prompt and other tactic, we will have faster feedback loop rather than fine-tuning. And in the case that if the fine-tuning you think is still necessary, and even though in this case the initial prompt engineering work is not waste, it still recommend let's start with prompt engineering before jumping to fine-tuning. So you can, if you want to use ChatGPT efficiently, you can go to OpenAI platform website. You can click on the prompt engineering guide. They provide a lot of technical for prompt engineering that you can use for ChatGPT. I think maybe our project we can follow this way. Let's start with prompt engineering first, then think about fine-tuning. And this is before we are going to the demonstration of my Canvas GPT. This is the thing I will explain on tomorrow. Tomorrow I will explain the React prompting. This is the prompting. They are getting popular day by day. Technically, React is just another way of RAG, but the way they find information is very good. So I will talk about React tomorrow. And for RAG, we can improve the RAG by building a knowledge graph. So far, right now, I am applying a knowledge graph for Canvas SQL that uses send a text. I will apply knowledge graph to find table and column in our database and apply some knowledge about graph processing in computer science to find a path to connect this table, other table, and perform the SQL execution. The next one, we will create a metadata, because when we applied hybrid search, we also applied the word base. And as I mentioned many times, the word base is strongly depend on our keyword. So in this step here, we will create metadata to find many keywords as possible. This is one example of metadata. That the text, this is the original text. You can think that is the call from our agent, but this text we can add many attributes such as the start character in the long paragraph. We can add some node IDs in our if we implement the knowledge graph. we can add some like creation date, file name position, the file size, or the class of the paragraph belong to. Yeah, that is a general approach of metadata. And the last one will be LLMOPS. Because when we working on the project, we don't when we working on the project after fine tuning, it's not stopped right there. Sometimes we have to refine tune again. Sometimes we have to maintain the search engine. So the whole entire process, so far right now, we are calling LLMOPS.
We call it LLM ops.
Yeah, LLMOPS. So maybe if you learn, if you read about machine learning, you know about MLOps. Yeah, so this is just LLMOps. That this is the basic step
from the cloud providers, right?
From cloud providers or from our PCs. So this is the general diagram of LLMOps. That we select a foundation model and then the prompt engineering. Then we start evaluating the result, and we can see that should we need team or label the data or something, and then we go back to maybe change the prompt engineering or reevaluate the result, or maybe we need to fine tune the model or update the result. The entire diagram right here is a LMOPS. So tomorrow I will explain about that, and looks like maybe we have to apply this diagram on our project. Okay, so now let's go to the Canvas GPT. I think some knowledge about Canvas GPT we can apply in our projects. The Canvas GPT, technically, it utilizes ChatGPT for providing user manual information. In Guangzhou Jisa right now, we are applying Canvas ERP system for one company. So in Guangzhou Jisa, they provide a user manual, how to use the program, how to install the program, how to adjust the program. The data is quite long. So at that time, Ihonjun Sangmunim asked me to use ChatGPT, apply ChatGPT to generate the answer. Because every time that company just called to Dfocus many times, and lots of people kind of like they got quite busy. So by applying ChatGPT, we can reduce the time. So this ChatGPT is specified for Canvas ERP system. The technique, the technique in the Canvas GPT is are similar to Dfocus GPT, but I have some adjustment in this version. That I applied the hybrid search with re-ranking in this version, and because this problem is purely based on RAG, so the position bias also exists. So I try to have a prompt and a technique to avoid position bias. That I develop a prompt for selecting strongly relevant information. I will explain that information later. And in this technique, instead of applying one prompt, I apply a chain of prompts. That I think maybe in our work, we also follow the chain of prompt.
Canvas GPT is ours or
It's ours.
customers?
It's ours. Yeah, we
We
develop.
have two GPT.
Yes.
Dfocus and Canvas.
Yes. Canvas is specified for Canvas only for the company, for our customer.
GGM.
Not GGM.
Surplus.
Sample.
Sample.
Yeah.
Ah.
We apply for Sample first, then Ihonjun Sangmunim plan to expand to other companies. At first, I also plan to Surplus Global, but they're afraid of data privacy, so they quite hesitate on working this. So this is my chain prompt work. You can see that given the query from the user, I can show here, they will pass to many flow of prompts, detect the language, rewrite the query, apply for search engine, and there is a reason if the search engine cannot find the data, we need a prompt for not answer the data. And even though if the search engine can find the data, but no data can be selected, then we have to say sorry. But if we can find the data, then we have the prompt for answer generation. So this is the basic diagram. So let's go to each diagram. In the sample, sometimes the user asks in Korean, sometimes they ask in English. So the first prompt is that I will use the language detection prompt to detect the language of the user input. And after detection, this language will be passed to the answer generation to say, okay, now the user is in maybe Chinese. Let's answer in Chinese. So thanks to the language detection. The second prompt is that is I call query rewriting, because we are using user input for search engine. So at first, in order to make the search engine useful, we have to make sure that the input is useful. So let's consider in this case. Usually when we talk to ChatGPT, we talk in the flow. For example, first someone say, who is Donald Trump? The answer will be, Donald Trump is a billionaire. And the next question is, was he the president of the United States? By our daily talking, we know that he is Donald Trump. But in a search engine, all the search engine can see is only this. Was he the president of the United States? We have many persons is the president, Barack Obama, Joe Biden, many people. So in this context, he referred to Donald Trump. But if we input that sentence directly to the search engine, the result might not be related to Donald Trump, might be related to somebody else. So by query rewriting the prompt, the last sentence will be rewrite as, was Donald Trump the president of the United States? Then the search engine will make sense. We can search the good data. The sorry for not answer prompt, this will compose an apology if we cannot find relevant information. We'll just simply say sorry to them. Okay, so now how to avoid the position bias. Let's say now we have a search engine and we already retrieve many data. So it is first in the search engine, first we may have to make sure that we have to select strongly relevant data.
Is this Elasticsearch search engine?
The hybrid search, yes. In the search,
search.
Yeah, in the search I apply the hybrid search. For example, if some query is 수수 등록은 어떻게 하나요? Then the search engine might return data about 수주 대체. Maybe not related to 수주 등록, but in practice it's happened. So that's why we need a process to select really good data and put to RAG. Then in the data selection prompt, I will select strongly relevant data given the data returned from the search engine. So how can I avoid position bias? I avoid position bias by first, I run the prompt 5 times. Then on each time, I will shuffling the order of data. Make sure the data is not spent in order. I run 5 times. Each time the data will be shuffled in order. Then in the end, I will choose the data that being over 50% time selected. At that time, I can say, this data is quite consistent, might be really relevant to the input. Then I will put that data to the RAG. And finally, the RAG just simply provide an answer. So here is the briefly demo of my work. Okay. For some reason, why it cannot run? Okay, now it's run. So we have many modules from the sample. Let's say they work one rule about Yong'op. Then we will place one question such as the correct 등록. The process will start searching. You can see that there are some delay, about 1 or 2 seconds. Okay, this is a demo. You can see that they have some delay when during the searching. So let's begin again. We click on Yong'op. You can see that the prompt is very long, but let's see how much time they for delay. They start clicking. This one will be 1, 2, 3, 4 seconds. Then they start generating the response. The time delay may be around 3 or 4 seconds, and then generate the response. You can see that there are many things that can happen. So this is just a guideline to show the method for a customer. Yeah, they also provide a briefly answer and original information. If the user want to find out detail, then they can click on each information. User can switch to another module and then running.
I don't use ChatGPT as a Gemini,
Yeah.
usually it takes a
Tick.
couple of seconds,
Yeah.
right?
A click. Yeah.
So our Kanya's GPT is slightly slower than original ChatGPT. Can you say that, or
Yeah, kind of, because they spend time on search engine, and as you see right now, they are combining many prompts. So technically, they are calling many prompts before going to the final prompt. So that's why you see some
that's
delay.
the disadvantage of
RAG.
RAG as you showed?
Yeah.
Understand, okay.
So in practice, I have to try to manage this problem.
So then, when we have a Gauss platform, we need to check the original version's latency first, and
Yeah.
then when you apply our RAG, and then there must be some added
Yep.
latency issue. Okay.
So because right now we are paying for ChatGPT, so the latency is very small. Looks like real time. So that is the reason I can apply the chain prompt. The latency is too large. Maybe I cannot follow this way. I have to try another way.
Okay.
I believe them. They are big tech, one of big tech. So I believe them.
They can be faster.
Yeah.
사실 시간 자체는 한 5초 안에만 처음 응답이 나와주면은 억셉터블 하다고 생각하거든요. 중요한 게 항상 답변 퀄리티인 것 같아요. 3.5 GPT의 경우 옛날에 답변이 정말 0.1초 만에 응답이 생성되는데 필요 없을 경우에 이제 유저들이 계속 물어봐야 되고